Instron Chest 9340 drop weight tester is a floor standing system designed to deliver impact energies from 0.30 joules to 405 joules. The corresponding falling weights range from 1 kg to 37.5 kg. With a full range of accessories, the system is suitable for many applications, including tensile impact, penetration testing of plates and films, testing of pipes and small components. This machine consists of three main parts: a turret, a test chamber and a control box. The turret is the upper part of the machine. Inside the turret there are a motorized crosshead positioning system, set of weights to deliver a range of impact energies, changeable tops and inserts for different applications, anti-rebound system preventing secondary impacts, photocell used to measure the velocity of the top just before the impact and to activate the top anti-rebound system. The base is equipped with a thermostatic chamber for specimen conditioning and testing between -50 degrees C to 100 degrees C. The chamber is heated by means of thermal elements. It is cooled through liquid nitrogen taken from an external tank. Different stands can be used for testing depending on the application. This machine is currently equipped with two stands: fixed high stand for single specimen support up to 25 mm thickness and support stand for compression after impact testing. The control box is attached to the right side of the turret and is provided with the remote operation mode, including power on, emergency buttons and LCD display. Impacting of the specimen can be controlled by the control box. Chest impact software is used to display and analyze recorded data, which is transmitted via data acquisition system. This impact tester will record the load and deflection during the impact event. These data are essential to understand the impact resistance or impact damage of specimen. In today's demonstration, we will perform a puncture test on a carbon fiber reinforced laminate. The laminates were manufactured by laying up 20 layers of woven carbon fiber prepreg. Afterwards, they were vacuum-bagged and autoclave cured. Each specimen has dimension of 150 by 100 mm and a thickness of 4.3 mm. Let us prepare the machine for the test. Once the power is on, the machine needs to be calibrated to the home position. After that, switch on the data acquisition system and run software on the PC. Next, we need to set up the test method in the software. The specimen will undertake the puncture test according to ASTM D5628 testing standard at room temperature. The impact energy selected for this testing method is 30 joules. The specimen support has a diameter of 40 mm. 0.5 kg of additional mass is added to the top holder for this impact event. The sampling frequency is 1000 kHz. The clamping and anti-rebound options are enabled. In the next step, a photocell is adjusted based on the falling height and specimen thickness. This allows an accurate measurement of the velocity just before the impact. In this case, the photocell scale must be set at 19 mm. Afterwards, the specimen is loaded into the chamber. Before the test, the specimen is automatically clamped. This machine comes with a clamping device which allows for the clamping of the specimen on the support with up to 3 kN force before the impact. Once all the parameters are determined, we can start the test. Inside the turret, the tap releasing unit first travels to the desired position, then drop the tap from that height. The sample could be partially or fully penetrated. If the penetration of the specimen is partial, the anti-rebound system will clamp the tap to avoid bouncing. Finally, the tap returns to the original position and data is transferred to the software. Data can be plotted in many forms. For example, force versus displacement, force versus time, impacted energy, and so on. The software has post-processing function of the results. Now let us examine the impacted sample. There is clearly some visible damage to both surfaces. Often impacting with lower energies causes invisible internal damage. To fully investigate the damage tolerance, other techniques such as CT scan are employed.